All right, so let's look at serial. Serial is a protocol, right? So it's a communication protocol that allows you to not just communicate with a microcontroller from your computer, for instance, by uploading code to it, but you can also upload uh, messages and so forth from the microcontroller, communication from the microcontroller to your PC, and it will be shown. If you see this button here to the top, it will show it in this screen here. So at this point, I have uh, some data coming back. It says temp value equals 3. And if you look in the code, um, this is the first line, temp value, and then the second line, I've got C, which is a variable, and C equals A plus B, which is 3, if you say 1 plus 2. So that is displayed on your screen. So let me tell you more about serial. The first thing of serial is, yes, it's a built-in function, and you have to start it up by saying serial.begin and then the speed that it should start up at. Now, if you look here at the bottom, here's speeds as well. 9600 baud, it's the same as this, but yes, you can go down quite far if you want to increase the speed. I seldomly say go above 9600 baud because you can see how fast it reads anyway. Plus, I have a delay of 500 milliseconds, so a baud rate of 9600, in my opinion, is more than enough uh, all of the time because you seldomly need to read things faster than the speed of light. Well, not really the speed of light, but I think you get the idea. So once you've set serial.begin and the speed, you see the speed here and the speed here must be the same, else it's going to be out of synchronization and you'll just see a lot of gibberish on the screen. To use it, you say serial.print or serial.println stands for line. So if you say serial print, it will print the value, but it won't create a new line. As you can see, it said temp value, but it didn't create a new line. Although serial print line C, which is variable C, do have a print line. So you'll have temp value and then the next value, which is C, and then the new line. If you don't have this ln there, it will just continuously print everything from the left to the right as one huge line. So you'll often do it in this fashion. Always and always use a delay. In this case, it's half a second. If you don't, it's going to move so fast that the next time you want to upload something, you'll probably find that you're going to struggle upload something because that line, that serial communication line, is occupied all of the time. Always a delay will save you a lot of headaches. Then, if you do not see anything printed after you've done this, go to tools and ensure that this USB CDC is enabled. If it's not enabled and disabled, change it to enabled. Compile your code again, and then once it's uploaded, press the reset button because sometimes with the upload, things happen so fast that serial don't get time to start its execution process. So always press the and it's this button here, just next to the to your USB connector is a button. It's your reset button, and you'll see it then works. So that's the one thing that can go wrong, is not choosing this CDC on boot to be enabled. Except for that, you'll be good to go. Something also to note is that you, of course, these variables is not set in stone. I didn't mention that previously. For instance, a temperature sensor, the value will change all the time. So every time you read the value, let's say it's in A will be updated with a new temperature value, and you will then print out the new values and so forth. So you constantly will update your variables by reading data from a sensor and so forth. Now, as we continue with this course, we're going to create AI code, and what we're going to do is explain more about conventional programming, and I'll show you, for instance, how the temperature sensor value has been read. Because there is many other functions, and one of them is to read a temperature value, and the temperature value is in volts. Remember, we can only read and write volts on a microcontroller. A 2 volt might mean 10 degrees Celsius, 2.1 volt might mean 9.22 degrees Celsius, and so forth. So although we stop with conventional coding right now, we're still going to look at things like reading code. The AI will do it, but I'm going to highlight how he did it in the code. Also, something else to keep in mind is that we're going to create master prompts, and what will happen is in that master prompt, I'm specifically going to tell the AI to create short little conventional coding lessons to teach you more about coding by using the code it generated as an example. And it will be the same for hardware. It will give you a little piece of description of what the hardware is and some details around hardware. In the beginning, you'll read it and you'll get more and more familiar with it, to a point where you'll take your master prompt and remove that so you don't get all these lessons anymore. So conventional coding is there for the curious, but it's also there for the person that likes to know what happens under the hood. So I'll see you in the next section that's all about AI and AI coding, and we'll start implementing our master scripts with our pinouts in it. I'll see you there. And please do one thing for me. Just open up your help, go to references, and look at the variable types that's there, how variables can be used, and just play around creating more variables and so forth. Before I forget, and this is very important, you can see that I said temp value here at the bottom, but you can also see I put it in double quotes. Double quotes tell your Arduino IDE that it's text. If you don't have double quotes, it will think that you have a weird variable, or it might even look like two different variables that does not exist. So variables don't get the double quotes, but text will need that double quotes, else your code is going to fail and not compile. So I'll see you in the next lesson. Bye.